Welcome to week 1 of the linear algebra course. This week, you will learn what a system of linear equations is and some of its representations. One of them is as a set of lines in the plane, and another one is as an array of numbers called a matrix. Furthermore, you will learn what singular or non-singular systems are, and why is this so important in linear algebra. Linear algebra has applications in many fields of science and technology, and machine learning is certainly not the exception. In fact, it is not a stretch to say that linear algebra is the most useful and widespread math field in machine learning. In this video, you will learn about some of the best applications of linear algebra in machine learning, starting with the most popular application that you may know, the neural network. Undoubtedly, one of the most popular and ubiquitous machine learning models is a neural network. Neural networks are used for many cutting-edge applications such as image recognition. For example, neural networks can be trained to take an image such as this one and be able to tell with very high accuracy if the image is a face or not. And how do neural networks work? Their functioning is the topic of an entire class, but let me tell you in a nutshell how they work. Say you have an image, which is the input. The neural network takes the image pixels as input and performs many arithmetic operations on these values in order to get a final value which indicates if the neural network thinks the image is a face or not. And how do we decide which parameters go into the mathematical operations to use? The data helps us as we pick the parameters that make the best predictions for the existing data. But here's where linear algebra comes into play. You see these dots organized in layers? Those are the nodes of the neural network, and they're meant to loosely mimic the behavior of the brain. It turns out that these layers can be expressed as rectangular arrays of numbers, which are also called matrices. Matrices are one of the fundamental building blocks of linear algebra. In order to perform all the vector or matrix operations to go from the image in the left to the prediction on the right, one uses linear algebra and calculus. Detecting objects in images has been a long-term challenge for machine learning that has seen huge advancement in the recent years. As you can see in this picture, the neural network is successful in detecting people, traffic lights, cars, trucks, and even small personal items such as a handbag. Remember, the image pixels are simply values that serve as the input, where the algorithm performs mathematical operations to determine the output. Aside from image recognition, where you can get computers to see and recognize what's on them, neural networks have numerous other cutting-edge applications. So as you can see, linear algebra is used all over the place in machine learning, and that is a great reason for you to master it. In the remainder of this course, you will be learning some very important concepts and techniques in linear algebra involving matrices, linear equations, linear transformations, and much more. Ready? Let's begin.